So we do this experiment in another class called General Chemistry 1, where we start with aluminum and we kind of like dissolve it, and we're trying to recycle. This is basically what some recycling plants do when they take in your soda cans and stuff. And so the question is, if we start with 5 grams of aluminum, how much gas is made? Because you need to know how big the container has to be to do this reaction. If it's too small, then, well, it's going to explode because gas is going to build up pressure. So the first thing we have to do is balance the reaction. So that's going to be step 1. I've copied it over to a new slide. You could use scrap paper if you need to. So when we balance a reaction, I'm showing it in purple because it matches what I circled here. Okay. So when we balance a reaction, we start with the metal. So there's one aluminum over here, and there's one here. So far, so good. Then potassium is a metal. We have one of those here and one over there here. And then we can choose oxygen or hydrogen. It doesn't really matter which one. All right. And I got to be careful because oxygen's in 2 places here. There's one oxygen here and one here. So I've got 2 right now on the left. On the right, I have 4. This 4 distributes inside the parentheses. So 4 oxygen. So that doesn't match. Let's take an initial count for hydrogen as well. We have 1 hydrogen here, and we have 2 here. So that means I've got 3 to begin with. Over here I've got 4 plus 2, right? Because there's this 4 applies to the H and the O, and then this 2 applies to this H. So we got a total of 6 right now. Alright, so since hydrogen and oxygen are both messed up, I'm going to guess that if I change water, it might fix it, because it has hydrogen and oxygen in it. So I'm just going to put a 2 there and see what that does. I picked 2 just because, these are basically almost, half, right? So it seems like if I multiply by 2, it might work. It doesn't change potassium and aluminum yet, so that's good. Oxygen now has 2 here, plus that one. We can't forget that one. So now it's 3. Right? Okay. And the hydrogen is still got this 1, and then 2 times 2, so that's 4. So there's 5 hydrogen right now. So that wasn't quite it. If I put a 3 here, we'd get 6 hydrogen there, but then there's a 7th one. So that actually is too many. We've gone too far then. So that's not it. I think the only option I have is to also put a 2 here, because if I don't, this is always going to be an odd number. This is going to be an even number. It's going to be multiplied by 2. So I must have to mess with this as well. And by doing that, I just messed up potassium. Uh-oh. We'll deal with that in a sec. Let's just count our other atoms, our oxygens here, and see what that means. So 2 oxygens here, 2 there. That's 4. So far, so good. 2 hydrogen here plus 2 times 2. That's 4 hydrogen. Plus the 2 from the K. So 6. So now our oxygen, our hydrogen's balanced. The only thing that isn't balanced now is K. Unfortunately, that means I have to put a 2 here because there's no other way to fix it. I can't put a subscript. That's breaking the rules. And by putting a 2 there, I messed up everything, since there's all the elements in this. Alright, so there's 4 O's for every molecule, and I have 2 molecules, so that means I've got 8 there. And there's 4 H's times 2, so there's also 8, but then also I have these 2 here. So there's really 10 10 hydrogens there. Oh dear. Okay, well the aluminum's pretty easy to fix, right? So now it matches again. Our oxygens are back to not matching. I need to have 8. I need to have 8. Well, I have 2 here. I'm going to try not to mess with that again, because if I did, I'd mess up the K. So if, I'm going to erase that so we have some space. Oops. Wrong button. Don't get too excited. We're not finished yet. This is just step 1 of this problem. Okay. Okay, good. So instead of putting a 2 there, what if I put like a 3? What would that get me? I'd get 3 oxygen plus 2 here. That'd be 5. That's not enough. I needed 8. Okay, if I put a 4, that'd be 4 plus 2. That's 6. Nope. What if I put a 5? 5 would be 5 oxygen plus 2 is 7. No, okay, it must be 6, because if I put 6, I get 6 oxygen there plus these 2, 8 oxygen. Okay, so at least the oxygen balances now. Now let's count up our current hydrogen. We have the 2 here, and 6 times 2 is 12. So I've got 14 hydrogens. All right. Now on this side, we said 10, but I'm going to have to change something. I have the 8 here. I don't want to mess with this if I can avoid it, because it would mess everything else up. But this has hydrogen all by itself. So let's see. If I have 8 from this one, and I got to get to 14. Well, let's see. 14 minus 8. We get 6. I need to have 6 hydrogens from this, which means if I put a 3 here, there, it's balanced. This is a tough one. Okay, I would probably not give this to you on a test, but even if I did, you just take your time with it and work through the steps and have faith that eventually everything will come out. All right, so if you need to write this down, pause it and go ahead and write it down. I'm going to clear some space for the next step. Okay, so our next step says to determine the moles of aluminum. What? Okay, crazy computer. Determine the moles of aluminum. All right, that's going to be based on the grams we have to begin with. That's the only starting point I have. So, 5 grams of aluminum. And you'll notice I always put the unit and the chemical together, because when we're doing these problems, it's going to change which chemical I'm talking about at different steps. So 5 grams of aluminum. I have to turn that into moles because I'm trying to figure out how much H2. This is our goal. And so I can't compare grams and grams. I have to go to moles. And so the question is, where do I get the relationship between grams of aluminum and moles of aluminum? And the answer is the periodic table. So it says there's 26.98 grams per 1 mole. So in other words, 1 mole of particles would weigh 26.98 grams. Okay, well, grams is the unit that I have here, so I want to put it so that this unit will cancel. So I'm going to put grams on the bottom. That means the number has to go on the bottom as well. They have to be stuck together. And I'm trying to get to moles, so I'll put that one on top. Okay, so now every moles of aluminum is where we're at. What I'm going to enter in the calculator is going to be 5 divided by 26.98, because that's on the bottom again. And we get 0.1853. I don't need to keep that many figures. I only have 1 in my initial data, so I'll just go 185. And I label it with a unit and a chemical. Alright, so that's step 2. The next step in this process is to determine the number of moles of potassium hydroxide. Potassium hydroxide, oh, you know what? Actually, that's not really relevant at all. We don't know how many moles of potassium hydroxide are. This is, cross that off, we're not going to do it. The reason I know that is because the question doesn't tell me like anything about the grams or anything involving the potassium hydroxide, so we're not going to do that. The next step we're going to go to is 4, actually. We're going to use a mole ratio to convert from aluminum to hydrogen. Alright. So, let's see here. I know that I have this many moles of aluminum. And I know the relationship because I just spent like 10 minutes balancing this reaction. I'm trying to get to hydrogen, trying to cancel aluminum. Aluminum has 2. Hydrogen has 3. Okay, so I cancel the aluminum to get it out of my way. And what I put in a calculator is 0.185 times 3 equals something, divided by 2 equals 0.277984. I do not need so many numbers, so I'm just going to keep 3. So it'll be 0.278 moles of H2. Okay, and then finally our last step is going to be to use the molar mass of H2 in order to calculate the grams of hydrogen. So I start from that number there. And I need the mass of hydrogen, which comes from the periodic table. Right? So basically I'm going to multiply our number here by 2.02. And you get 0.56. That would be grams of H2. Okay? So that's how we do this kind of problem. Now, the other kind of problem that we might get is if they did give us KOH, what if they say, for example, let's say this part wouldn't be there. It might say if I use 5 grams of aluminum and, I don't know, 3 grams of KOH, how much hydrogen is made. So what I have to do is the same process for KOH and see how much is made, and whichever one is smaller is the answer. Okay, so let's try that. Oops, wrong direction, I'm sorry. So kind of using the same process here, if we have 3 grams of, wait, I said 3, right? Yeah, 3 grams of KOH, let's see what happens. So, step 1, we go from grams to moles of that stuff. Right? Ignore that. So 3 grams of KOH, I have to figure out the weight of KOH. So you can do this on the side of things if you want, but make sure it's legible and has units, because if it's not, I'm not going to know where to look, you know, when you send in your work for this chapter. So K says it is 39.0983, so I'm going to just write 39.1 plus O is 16.00 and H is 1.01. Alright, so we add all this up, 39.1. Alright, so we get 56.11 as our answer here. And the unit that I want you to write at least at the end, so that I know where to look for. I'm looking for units when I'm grading these things. So 56.11 grams for every mole of KOH. I have to put that on the bottom again because I'm trying to cancel grams. Now, I'm going to show you something kind of cool actually. Let me see here if I can fix this. Okay, so actually I'm going to work down here in the bottom, and I get a little more space down here. So we have the same thing as we start there. 3 grams divided by 56.11 is the math. I don't actually have to solve for that. I can keep going because it's all multiplication. It doesn't matter if I do it one step at a time or if I stack them all together. Okay, so the yellow is when we went from moles of one thing to moles of another. Okay, so in this case we're trying to get rid of KOH, so we're going to do 2 KOH on the bottom. And let's see, we're trying to get to our product, which is H2, so that's the same as the last step. So in kind of a cool way, what I can do is cancel my units sort of as one problem instead of separate problems. So here the grams cancels, here the KOH cancels, and now we got moles of H2. The next step is to go to grams of H2, and that step's going to be the same for both of these. So we're going to take the mass from the periodic table to cancel moles, right? So one big problem in the benefit of this is it's faster. I don't have to compute, I don't have to grab my calculator one time. So once you get comfortable with dimensional analysis, this is a great way of solving problems way faster than if you do it step by step. So in terms of the math, I take 3 divided by 56.1 because it's on the bottom there, and I hit equals. That's just some number, I don't care what it is, times 3 because our 3 hydrogens here, and it equals something. I got 0.48. Divided by 2 because I have a 2 on the bottom, equals something. And then multiply that by 2.02. And we got 0.243 grams of H2. Okay, so you don't have to write it out step by step. You can do all the conversions all at one time. If you like doing it step by step, I'm fine with that as well. Okay, it's just faster. So we get 0.243 grams if we base it on KOH. we get 0.56 grams, which is more than twice the amount of product when we base it on aluminum. This means that in reality, we are going to make only 0.243 grams. All of the KOH gets used up because of this reaction. Not all of the aluminum is used up, so that means that the KOH is our limiting reactant in this case, in this reaction. You might even be asked an additional follow-up question, something like how much aluminum is left? Well, to figure that out, we can subtract these two and kind of do the process backwards to figure out how many moles of aluminum would be left over. Okay, so that's it for this chapter. You need to finish the homework that I gave you last week, and we're going to go over that in class. It is graded, so make sure you finish it. You should come see me. Don't wait until Tuesday to look at this, okay? This stuff is hard. You need to practice it. In addition, we're going to do a little bit of extra problems here. So we're going to do a few additional problems from the textbook at the end of chapter 12. There's a discussion question section first. That I want you to do one of those, number 5. And then a couple of these problems in the subsequent questions, exercise, and problem section. These are going to be graded, and they're going to be worth a significant number of points. And I'm not looking for correct answers here. I am looking for the correct processes. So you need to use dimensional analysis for everything. Okay? You need to show all your work, especially molecular weight formula calculations. Okay? So the stuff you're getting off the periodic table. Don't just write random numbers down. Show me that work. Okay? We're going to bring this to class, and not only is it graded, but we're also going to go over it and discuss it. So when you have questions, I want you to write them somewhere, maybe on a separate piece of paper, or highlight them. Make sure you can find the questions really easily. So as you go along and you wonder, gee, I wonder why that is that way. Or what do I do here? Highlight that kind of thing. So we can go over that in class and really focus on what we need to focus on instead of, talking about things that we already understand. Okay?